Hi, everybody. Naya is running a little bit late, so we're going to go ahead and start the intro to game design. I want to go ahead and introduce Joyce Lee. I hope I didn't say your name wrong. She is going to, or he is going to take you through the workshop. I hope you guys downloaded Unreal Engine 4. Thank you so much.
Cool. Hi everyone. I have like a 2-computer setup. So if I'm looking away, it's not because I'm not looking at you, it's because I'll be demonstrating the workshop portion of this on my other screen. But I think there are some slides I can share. So let's talk through that first. Let's do this. A little preview of what we'll be building. You can see how often I've used slides, I guess. Well, anyway, so hi, my name is Joyce. I'll be presenting today's workshop, just kind of a little intro to game development. We'll be doing the workshop mostly in Unreal. For those of you who are not familiar, it's an off-the-shelf game engine by a company called Epic Games. They're based in Raleigh, but they've just because it's been used by an increasing number of industries and also game companies tend to be a little bit scattered, some in Chicago, some in California. They actually have a presence in a lot of the country as well. You probably know them because they are the company that created Fortnite, among many other very popular games. So a little bit about me. I'm currently San Francisco based. I'm guessing many of you are, or as well. I'm originally from New York, so transplant to California, but I love it here and I don't think I'll ever go back. I am a UPenn class of 2016. And STI, I don't know if there are any STI grads out here, but STI class of 2013. A little bit about my work experience. I've done a bunch of AR, VR at Google. That's kind of how I got into game development. You wouldn't necessarily think of Google as a games company, but what with Daydream and Stadia, there are parts of the company that have been heavily involved, and so that's kind of where I ended up within Google. More recently, I've moved on to work on ADAS, so that's Advanced Driver Assist at both Tesla and Rivian. I guess the tie-in here is that at both Tesla and Rivian, we use Unreal to do a lot of our development for vehicles that we do development for vehicles, the software that we put on vehicles before we put them on the road. And so that's one way that we can iterate faster, but also improve safety because we're not, putting several tons on the road driven by software that we're testing for the first time. On the side, I have a little project car. I have a little Miata. I don't know if there are other Miata fans on this call. Yeah, that's a little caricature of mine. So we'll be talking through a few things today before jumping into the more hands-on component of it. So first we'll talk about what are off-the-shelf game engines, what are they good for? And then we'll go into kind of the basics of using not just Unreal, but any game engine. And then more specific to Unreal, whether you want to use coding or scripting, that's always a choice you sort of want to make up front, and then we'll go into the more hands-on portion. I realize that it's kind of a long tutorial, so if we don't get through the whole thing, I'm happy to package up my project and then share it with all of you afterward. Also, please feel free to stop me at any point. I'd like this to be interactive. Stop me with any questions that you have, or if I'm going too quick, just let me know. What is a game engine? So if you just do a quick Google, the top hit says it's a software framework designed for the development of video games. hence the name game engine. But I think that's really drawing too small of a box around what game engines can actually do. We're starting to see them pop up in all sorts of other places now. Things like in the industrial world, we're seeing them do like robotic sims, like assembly line sims, or like the physics components of that, just verifying like if you've ever watched like how it's made, it's not just the mechanical components, it's also how materials and the product moving through the assembly line interacts with it. All of that can be simulated in game engines. Like I've worked on projects where we did like a forklift like training session in a game engine in VR, because it was safer to train in a VR forklift than it is to train in an actual forklift. In the automotive world, which I touched on, that's where I've mostly been applying game engines as of late. So that's everything from simulating sensor data that's coming from the vehicle, so that we can iterate on like the driver assist systems without needing to put a vehicle on the road. That's stuff like here at Rivian, we use it for our driver display. So like when you're, when you're driving and it's showing you kind of your surroundings, if any of you have seen renders from Tesla, it's very similar to that. We create that view using a game engine. Architecture and real estate. I don't know if any of you were trying to move during COVID and it was really hard to get an open house anywhere. A lot of companies have taken to, I think Matterport is well known for this, scanning the unit that they're trying to sell or they're trying to lease. That's for existing units. A lot of like companies in China now are doing purely renders. They're trying to sell units that aren't even built yet. They've just created it in a game engine, and trying to sell people based on that alone. So that's really changing real estate as well. Film and TV, it's both a new and old and new use of game engines. So historically, game engines have been used as like kind of the previs, so to kind of just lay everything out before filming actually starts. But lately, it's been used for things like The Mandalorian. So The Mandalorian was all the background was rendered in Unreal. So we call it real-time projection mapping. Basically, there's a big green screen on there used to be a big green screen in the back. Some scenes are still filmed that way, but the other way they're filming it now is just putting like a giant, super bright screen behind the actors and just filming it directly on like a screen. So you don't really have to do with comping the actor back in. It's really incredible, and the fact that it's real time and it's gorgeous. I think it's really pushing TV forward as we know it. And then retail is the last one. Retail is, you see, especially these like high-end clothing makes, designers, they want people to be able to like try on their clothes before they actually buy them. That's one thing that game engines have been used. The like cloth simulation these days is really good. It's fast. And so people can interact with their clothing. Like clothing isn't static, so they can interact with their clothing even before they buy it. Furniture, we've seen furniture, people like IKEA, Amazon trying to show you your furniture before you buy it, see it in your space. The original first pass of that I think was pretty bad because it looked like a sticker, but now there's starting to be like volumetric understanding of your space. They can even incorporate lighting, so you can see how like that new furniture would actually feel. I think it's actually really cool stuff. I've used it to buy some of the furniture, like my office furniture when I was building out my home office like a year and a half ago, 2 years ago. Wrong computer. So let's talk about where you can get started with game engines. So there are a couple options, not too many options, but both of them are way better than trying to build your own game engine. You can imagine like you'd be building like your own build pipeline, your own render pipeline, your own like editor. it's a whole mess. So you have two, honestly, both very nice off-the-shelf options. I've used both of them extensively. One is Unity. I gave a talk last year using Unity. I think between the two, it's probably more beginner friendly, if you will. If you've never written code before, if you've never used the game engine before, I think it's a little bit more friendly to get into. But of the two, I think Unreal is more powerful. It runs faster at the end if you're concerned about that. It's known for its better lighting model. I think that's the reason why a lot of industrial and like film use cases tend to choose Unreal over Unity, just because of that realistic fidelity. So basics to know about any game engine. The first is scene hierarchies, transforms. I don't know if there's a way I can take a quick show of hands, but how many people here are familiar, have heard of this before? Anyone? Okay, that's okay. Let me see if I can doodle on my screen. So the idea is actually pretty simple. So you have, let's say call this a root. You have a root of your scene. So this is like your world, like 0, 0 is the origin. If you go north, you increase in X or Y, pick your coordinate system. It's pretty simple. It's your cardinal directions. And then after that, you can do what we call parenting. So these we call children, and then we attach these to the root. So here, each of these are representations of objects in your scene. This connection allows you to apply what we call a transform. So transform is position, relative rotation, relative scale. And so what that means is, let's talk about scale, because it's the easiest one to understand. If you scale a child by 2, and then you have another child, and then you scale it by another 3, this relative to your world is actually 6. So the reason this makes this easier to work with is you can imagine like you're creating a human, a human like myself. Your transforms might be at your shoulder. So now I can rotate my arm and not have to care about where my arm, where my, excuse me, like where my hand is. I can also rotate at my elbow and then rotate at my shoulder. That preserves everything below my shoulder without me like going and explicitly placing, like put my elbow here, put my hand here every time I want to rotate. So that's why transforms are nice. It makes it easier to manipulate your scene, and it's kind of just how we think about the world too. Like we don't think about the world as like everything moving independently of each other. We think about it in terms of like the larger object that they belong to. Cool. So the next one is scene space versus screen space. So both of these engines, Unreal and Unity, are 3D game engines, which means that they natively understand the world in 3D space. You'll see 2D game engines out there. Those are mostly used for like mobile or flash games back in the day. Pretty much everything that's commonly used these days are 3D, just because if you think about it, you can always take 3D and make it 2D again. So the difference between scene space and screen space: scene is your 3D environment. Screen is, you can imagine, screen space. It's like the heads-up display that tracks where your screen goes and not necessarily objects in the scene. The reason to differentiate that is like whenever you create a new element in your game, you kind of want to think whether you want it in your scene or in your screen. A screen, you'll have higher resolution. It'll be easier for people to see. They'll always be able to see it, versus the scene, which will probably move and change and have other objects coming in and out. Standalone versus in editor. So you'll see let me stop annotating. This is the editor. So you can see there's a lot more here. You have all these like how to say, panels. You can do a lot more in the editor than in the game. If you build a standalone game, you get only, the game you built. So like in this case, I made a little like car sim. This is what we'll be building today. If I were to build a game, that's all you would get. You would just get that interaction right there. The important thing to note here is when you build an editor, you get access to all the components in the editor, which is a lot. It's probably a lot more than you need for your game. So when you build out your game, you kind of strip down all the libraries. You get a much smaller executable, but you also have to make sure that you've included everything correctly so that your game doesn't go reach for a library and then find it missing. You'll never have anything missing in the editor because it's just always all there. Another thing to note that's kind of tricky is sometimes the naming changes a little bit. Object names can change a little bit. So I would caution just generally in developing with game engines is to be careful with identifying things by strings. If you can identify it by pointers or direct references, like that will always be safer. And the last thing is target platforms. This is something to sort of just think about as you get started making your own game. There are a lot of devices you can play games on these days. It's not just desktop computers. It's like mobile phones, tablets, a variety of devices. And what that means is you have to be cognizant of the capabilities of your hardware, how much compute power it has, how much memory it has, even things like just literally how big the screen is. If you're trying to target a phone, maybe not put a ton of tiny text. If you're trying to target like a console, well, people still have small TVs, but most people don't. So you can probably make your UI a little bit more tightly placed. Cool. Any questions? Okay, I'll keep going. Stop me whenever if anything I'm going over too quickly. And the last decision you have to make before you jump in is coding or scripting. Given everything we've talked about, you'll be building out your game's logic. You'll also be building out your game's assets between the two. So most projects are some combination of coding and scripting. You will probably never see a project that's 100% coding. You will see projects that are 100% scripting. And so what does that mean? So coding in Unreal means coding in C++. Scripting means it's called the Blueprint scripting language. It's built into the engine. It's proprietary by Epic, and it's a visual scripting language. So what that means is you don't need to have coding experience to be able to make things work in Unreal, which is a huge leg up. And also like C++ is kind of hard. So what a lot of people do is they iterate in the visual scripting language. When they're happy with things, or then they move it to code just because it takes longer to implement it that way. So the main trade-off, I would say, is coding. I would recommend doing coding if you're working on a collaborative project. One problem with Unreal is that everything is stored in a binary asset. This is actually true for both Unreal and for Unity. Most, we call them assets. Most assets you create in the engine are binary assets, which means you cannot have two people working on them at once. So if you put all your logic into an asset, only one person can edit that code at once. And so if you're working in a collaborative project, that's kind of problematic. That's one reason to choose to go with scripting. Code is also faster. You can optimize it. It compiles better. So if you have a lot of complex, low-level logic, coding is probably the way to go. And the last one I already touched on is it's just faster. It runs faster. It's not faster to write. It just runs faster. Scripting, it's faster iteration time. So one thing that for Unreal is you can script in the editor, and because it's interpreted at runtime, you don't need to compile. Well, you kind of need to compile. There's like a compile button that's just like a sanity check on your script. but you don't really need to compile in the sense as like you're not creating new like DLLs and loading them. So you do need to do that for C++. We'll touch on it a little bit in the workshop. Because you don't need to reload your DLLs, it's faster iteration time. It's also great if if you've never coded before, you're working with someone who's never coded before. It takes a little bit of getting used to, I think, but it's pretty straightforward to read and to understand. And the last one is UI and input. And this is the reason why I say you'll almost never see a project that's 100% coding, because UI input you always want to do in blueprints. It's just I would say it's not just the easier way. I would call it almost like the only way, because going back to what I mentioned about like strings, hard-coded strings, if you were to do UI and input in code, the way to do it in Unreal is just like hard-coded strings. And so that's very hard to read, very hard to maintain. Strongly recommend against it. So Unreal projects, you can set up.
Yeah. Does scripting run on zeros and ones, question mark?
Does it run on zeros and ones? So it gets compiled into C++. So under the hood, when you build your game, the engine will compile it into, actually, I'll be a little bit careful about when I say this. So C++, when you compile it, it gets translated to an intermediate representation. Blueprints get compiled into that same intermediate representation when it goes into code generation for your project. So yes, they run very similarly. Unreal's actually done, or Epic's done a lot of work to make blueprints run faster. When they first launched blueprints, they were substantially slower. It's closer, I would say, but it's still not exactly on par with each other.
Thank you.
Mm-hmm. Okay, so going into the walkthrough portion, got about half an hour. So once again, this is kind of what we're aiming to build. You'll have, what you don't see is I'm using my keyboard input. I'm using the arrow keys to kind of just drive this car around. You'll see in the, oops, where's my mouse? In the upper right, there was kind of like a speed indicator. So this is just a really super basic demonstration of like, you know, how you could build UI. And so you don't actually need anything to get started with this, as long as you've downloaded Unreal. So let's get started. So hopefully you've downloaded this Epic Games Launcher, set up an account because it requires you to. And I'm working on Unreal 4.2.7. It kind of doesn't really matter which version you're on. If you have a version downloaded, they're all very similar. 4.2.7, if you're working on Linux, they've made a lot of really neat new features for Linux. But if you're not, then it's all good. I would recommend developing on Windows if you can. Epic's support for Windows is much better than it is for the Mac and Linux. Sorry, if I was misstating it, develop on Windows. So you can see I have some old projects over here. But we'll actually be starting with, so like I touched on, you can work on games, film, television. This is basically all the game industry, the game engine use cases I touched on. But we'll be starting with a game, but we'll be starting with a blank one. You can see actually the other, if you're interested, check them out. They should definitely show kind of interesting features, that you can use. I like to start with the blank one just so that you can see, like, you can build everything from scratch. A lot of these are pre-built for you, and it's a little bit hard to pick apart like what was done ahead of time. So we'll start with a blank one. Similar here. I see Peter's comment that he installed the source code. Be warned, if you want to build from source, it's possible. It's actually like I do it just because I need to make changes to the engine once in a while. but it takes like a couple hours to compile. The first time you try to build the engine, it takes a while. So these pre-built installed ones, as long as you don't have to modify the engine, are definitely easier to and faster to get started with. And Epic will keep trying to like pipe you back, even if you do your own custom installation. They'll keep trying to get you to use these proper releases, if you will. So okay, so going through these project settings, we'll actually be doing a C++ template today because I want to show you how to use both C++ and Blueprints to get things to work. I'm working on a desktop and I don't need starter content, and I'm choosing no starter content. You can use starter with if you want to see what it looks, what's available, but this is just to keep my project kind of leaner. And I'm just going to call it SF Hacks walkthrough. And create a project. Takes a minute. When you work in game dev, you get used to seeing a lot of progress bars. So when you create a project, if you have Visual Studio installed, if you don't have Visual Studio installed, I would recommend it. There are free community editions out there. Unreal is able to generate Visual Studio solutions, which will make your life a lot easier when you're trying to develop in C++. Unreal's code has a lot of macros in them, which can be kind of hard to resolve and understand. It makes understanding compilation errors honestly kind of a mess. So yeah, I would recommend installing Visual Studio. You can see that it generated a project automatically here for me. And it will just make your life easier. So going back to, this is what it should open up to, totally empty, which is fine. And the first thing I would do is I would just save it as a new map. And let's just call it like, no spaces, first map, and save it. And that way we can always come back to it. What I would also do is I would go to the project settings, and then maps and modes. I would set that to first map as well. And this is just so when you start up your editor, it opens this map. You'll be restarting the editor somewhat frequently, so it's just nice to have. And then this one is when you start up your game, which map does it default to. We're not going to be building a standalone right now, but if you were to build a standalone, this is one of those differences where you have to specify where it opens into. Otherwise, it'll open into that default empty map that that you saw it was originally set to. So, okay, so let me see. Pulling up my reference code here. We'll be starting by creating a new C++ class. So you can go here, add new C++ class, and you can see there are a bunch of different options here. There's documentation on exactly what these individually mean, but basically you can think about an actor as just it exists in the world. You can move it, you can rotate it, you can scale it, you can do stuff with it. A pawn, you can think about like where your camera controls are, is the easiest way to think about it. And then the other most interesting one is your scene component. So that's like if you have a common functionality that you want a bunch of different kinds of actors to share, let's say like you're building Mario and you want the Goombas and the, oh man, I'm blanking. But let's say you have a couple different enemy types that you want to all take like hit damage in the same way. You can create a component that's just like take hit damage and then reapply it to multiple kinds of actors. So that's why it's a component. So I'm I'm going to start with creating an actor because I want to make a car. So I'm going to call this, let's call it a vehicle. Let's call it vehicle. I'm not going to call it include actor in the name because what Unreal does is that it prefixes. So the object you'll actually make will be a vehicle. So A for actor, and it'll be vehicle. So I'll put it in public and then create a class. Also, if you hear my fans spinning up, I do apologize. My computer's a little bit on the noisy side. Cool. So you can see here, it created both a C++ and a header file for me. Like I mentioned, these are kind of like the macros that Unreal will generate for you. This one specifies the project it belongs to. I won't go into it today, but if you create plugins, these will indicate which plugins that they belong to. Cool. I'm also going to go back and create another class because I want my car to have tires. So I'll create a tire class. And reload all. Cool. So you can see here that it will have built this hierarchy. You can ignore the engine over here. This is where your solution, this is where your code actually lives. So underneath your SF hacks or your project name, this is your project name. If you go into the source code, you'll see these are your target platform. This is how you specify different build configurations for your different platforms. And then if you go and expand this, you get all of your source code. You'll see these are templates, they're for modules. I wouldn't, so the reason why you would change them, actually you wouldn't really change these, you would change the build scripts. If you have new dependencies, you would add them in the build script. But I wouldn't touch them, and I would be kind of careful about like avoiding accidentally naming the same thing as any of them because it gets the engine really confused. One thing that I have mixed feelings about for Unreal is that it puts everything in the same namespace, which is good because you can easily access everything, but it also means you have to be really careful about naming. That's why namespaces exist, because there will be naming collisions if you include enough libraries. So just one thing to be kind of careful about. So now you can see it's generated all of my files for all of these classes. Cool. So let's go back to the vehicle. So one thing that you're able to do in your C++ is actually, let me create the blueprint first. So what we're going to do in the C++ classes, the way you use C++ classes in Unreal is that you wrap it in a blueprint. So I'm going to create a folder here. Let's call it blueprints. Stay organized. Blueprints. Rename. Go into that, and I want to create a new blueprint class. And it gives me all the default options over here, but I want to expand this and I want to look for my vehicle class that I just created. select that. And then the convention is to name blueprints BP underscore, whatever. So I'm just going to call it BP underscore vehicle. Let's open up in my other window here. But so now you can see you have a bunch of these editor windows. And so indicated here is the parent class. If you click on it, it takes us back to this class that it inherits from. And so it's a pretty simple class right now. There's not a lot going on. So what I want to do is I want to create just a couple meshes. So you can go here, add component, static mesh. So static mesh is just kind of how to say, it's well, if you're familiar with meshes, basically all it means is that you're applying a mesh. It can hold a mesh that that doesn't change, hence static. So in this case, I'm going to use a cube. It should come from the engine, this engine basic shapes. There are a couple options, but I'm just going to go with a cube, and then I'm going to scale it. Let's see, I want this to be, make it just kind of more of a boxy type of deal. One thing to keep in mind is you want to decide your scale early on so that you're consistent. This is particularly important if you import meshes. You want to know if like 1 means 1 centimeter or 1 means 1 meter. That's not usually documented anywhere. So you just want to make sure you know what your 1 means. And then when you bring in assets from outside, they'll tell you what their 1 means, and you just have to do the conversion. But that's just one thing to keep in mind. Oops. I'm going to add another static mesh. Just to make this look a little bit more like a car. We'll give that a cube as well. Oops. Yep, that's the one I want. And then this one I will place at -10. And then I want to scale it 0.9, 0.5, and 1. Oops, that's a 0.9. No, hold on. -10, 60. So you can see what I did here. If I can scroll in gracefully. Maybe not. Oops. All right. What you can see here is this 0.9 is relative to this. So when I mentioned about the scales kind of stacking on each other, this is not actually 0.9. This is like 0.18 relative to the world. So this is kind of boring right now. Compile, save. You always want to hit compile just to double check everything's fine. We haven't really gotten into the logic side of it yet, but it's just it'll make sure when you hit compile, it'll reflect on all your other blueprints as well. So that's one thing to keep in mind. So this looks kind of boring right now. We can go back and make it more interesting. And the way we do that is I'm going to make a new folder called materials. So I actually, I think this is one of the places where like Unreal really shines. I think its material editor is really, really neat. So I want to create a new material, and I'm going to call it M underscore convention for materials. Call it M car paint, and then going to open that up. So this is the output. This is the output of your material. So everything the way you control your material, and this is a preview over here of what an object will look like. You can also try different things, cylinders, planes, just to see how they show up. Oh, this is the teapot, if you guys have seen the Stanford teapot before. And so what I want to do here is car paint. So the one I think looks a lot like car paint right out of the box is the clear coat one. You can already see it's a little bit shinier. And so we basically just want to add parameters. So you right click to pull up the options. And here I'm going to do a vector parameter, and this is going to be my base color. Double click this and kind of pick any color you want. Say I want a blue car today, and then just drag that into the base color. Pretty simple. You can also have different other controls. So scalar parameters. I'm going to call this one metallic. Metallic goes into metallic. I'm going to, in the interest of time, copy and paste from my other project that I have open. But you can see the other scalars, you can just plug right in. And the overall effect, you can kind of, I think that looks a little bit plasticky to me. It's probably because my metallic is set to 0. You can see if I change it to 1, now it looks a lot more metallic. So you can kind of tune these and play with them. It refreshes in the window, gives you a live preview. It's I think it's really neat. So let's save that and go back to our vehicle. You can see the material here. It's this gray kind of boring thing. And I want to change this to my car paint. Change that. And then change the other one as well. Okay, save that. And you can see it's got a little bit of like a skybox reflection going on. Let's take a look at our car again. So let's put one in the middle of the scene right here. It's not exactly in the right spot. Also, oops. Sorry, the camera, I'm using a laptop, which means it's kind of difficult to do accurate navigation. I would recommend a mouse for a lot of this work. I wanted the Y to be 0.5. Yeah, so you can see kind of a car-ish shape showing up now. Just to position it a little bit better, I'm going to center it, but I think just because my mesh is a little bit, oops, is that not right? The other way you can do this is you can just drag the arrows. So I want this to be a little bit higher. You can see that it updates live over here. So now I've kind of like a car-ish looking thing that's hovering above the ground. You can hit play now, but it's going to be pretty boring because what happens is you've got this kind of camera control, but everything's really static. And so you're just moving this camera around the space. So what we are going to do next is we can add a camera. So one common way to have a camera control is what we call a follow cam. So basically you have a character you're interested in a scene. And so you basically have your camera just kind of track that object that you're interested in. So I'm going to go back into blueprints, and then I'm going to create a new blueprint. This I also want to be an actor. And so this one I'm going to call it BP follow cam. And then I'm going to open that up. Let me see. I'm trying to hide the little bar, the screen sharing bar on top, because I can't see everything that I want to see, but that's okay. So what the most important bit about this is the spring arm. So the spring arm is kind of what you can see that it's got this attachment, and then let's put a camera right at the very end of that. And so now you can see you have control over where this arm, the distance that this arm is. So since we're not working in huge measurements, I'm going to make some additions to make it, how to say, follow a little bit closer. So let's save this. Close all this. So compile and save. And put this into the scene. And I can put this at 0 as well. So going back to this, basically what I want it to do is I want it to track the vehicle no matter where it goes. And so, oops. In the begin play, basically I want to set a target. So you can see the variables. These variables are automatically constructed from the components, but I can add my own variable, and let's call it target, because this is what I want it to look at. You can change the settings over here. You can rename it. You can also change the type. And so the type that I want here is I want my VP vehicle. And the blue is an object reference. That's the default one. That's probably the one you want. And then over here, you want to get master of class. This searches your entire level, your entire map for this object, and then assign it. So you want to find it here, the VP vehicle, and then drag this over, set target, set that. So what you also want to do is we have this concept of event tick. So an event tick is every, it's called basically at your frame rate, it's called every time the frame updates. And so you don't need to call it within a loop, just assume that it's going to be called frequently for you. And so what I want to do here is I want to get the spring arm. And then what I want to do is I want to set where it is. So set world location. That's not the one I want. Set world location. So it's this menu, it tries to be smart. You can uncheck the context sensitive if you want to search everything. But one thing to pay attention to is like what the node is actually being called on. There are a lot of similarly named functions that mean different things if they're called by different classes. So just one thing to kind of be careful about and make note of when you're in this blueprint scripting environment. And then I can go and get my target, and then I can get its location. And what I actually want to do is I want to preserve the camera's Z position. Sorry, I want to have a fixed camera Z position so that even if the actor like rises or lowers, like let's say this car like goes over a speed bump, I don't actually want my camera to bump with it. So what I'm going to do is I'm going to split this pin struct and then say I want my camera to always be at 120. I can also right click here and split this pin struct. So I do more or less want my camera to track the vehicle. So I'm going to just drag these over, Y into Y, X into X. Just one thing that improves the way the appearance of, I guess, this following. So I actually want to tilt my camera down. I don't want it to look at my vehicle head on. So I'm going to go into the rotation mode, and then you can drag over here to change the pitch to whatever you want. Save that, and then go back to my event graph. So I actually want to subtract minus, let's say 20 from my X position so that so my car is within view. So it's pretty close, but you can still see we're not really looking at the right thing yet. So one thing that's kind of hidden is you want to go to level blueprint over here. And what you want to do here is event begin play. Begin play happens when you click the play button in the editor. It also happens when you start a game. And so here you want to get player controller. Player controller is what your keyboard input goes to. It's what your mouse input goes to. And then I want to get a reference to this camera. So I'm going to click this in the level, go back to my level blueprint, right click, and you can see this create reference. So now, like, only from the level blueprint, you can access any actor in the level. And then from there, I'll do a set view target with blend, uncheck this, context sensitive. This is actually coming from the player controller. So set the new view target, compile, save. So you can see actually with blueprint scripting, like iteration time is super fast because, well, okay, so I need to kind of fix exactly where I'm starting it. But now you can see I have this camera. It's not really tracking the right object. It's tracking this yeah, it's not tracking the right object. So we have to go back and fix that. The other thing is that you might have noticed it added a big sphere. So the way to fix that is you want to go into the world settings and change the game mode. So you want to create your own game mode. And the reason for this is your default pawn class is what the player controller is. So you just want to change that to like a spectator pawn. Then it won't have any mesh attached to it. Save. Shoot. Not sure what happened there. Oh. Well, you can change that now. All right. Something went wrong there. Unfortunately, it looks like we're getting close to time. I would say Unreal is, it's got a lot of menus. It's worth noodling around just to figure out where things are and how they work. Yeah, once again, you can see that I'm not actually possessing the right thing right now. So if I had time to continue to work on this, that's the next thing I would figure out. One last thing I wanted to show in the interest of time, and once again, I'll package up my finished project. I'll share it with you for reference if you want to see how I build things. You'll see that, like, let's say I wanted to add things like a max speed for the car, and I wanted it to be configurable in this menu. So how would I do that? So I would go into this class over here. So there are a couple macros that are really useful within Unreal. So things like, I'm just going to paste one over here. So the macro is uProperty. There are a couple different options you can include in this metadata. You need at least, this one is optional. This edit anywhere means I can edit in the map. This blueprint read write means that I can access it from the blueprint scripts. And then this is a category, it's required, but it's for your organization. So you can find exactly which fields you want a little bit more easily. This uProperty, you need that macro for it to show up in the editor. The analogous one for functions, if you want a function that you can call, is ufunction. And then you can say it's blueprint callable. So this one you would implement in C++. I can move my finished one over here just for reference. But over here, I have a bunch of properties that I can assign to. And then these I don't have as edit anywhere because I want the blueprints to be able to use them, but I don't want people to be able to go in and directly edit them. And then the supply movement I have implemented in C++. Let me also just pull over my other completed. I think I was too ambitious with how much I could create in an hour, but you can see in the vehicle blueprint, we didn't really have a chance to flesh it out, but things that you can do very easily in your blueprint. So once you compile it, once it's compiled, it will show up on the side. It actually shows up. So those that you specify in your code, they'll show up over here. So this was the movement category that I specified. And then these are the individual fields that I can now set to anything I want. And I can do that without recompiling. So one annoying thing about working in C++ is in order for DLLs to reload, you need to build, shut down Unreal, and then restart it in order for the DLLs to take effect. And you can see how that can get kind of annoying if you're doing it, tens, hundreds of times a day if you're working on this, working on a game in earnest. Things that are easy in blueprints, like I mentioned, blueprints, input, you can do really easily. You get your player controller, and then you can get key down, you can get like mouse down. So inputs are super simple. And calling into that function that I declared in C++. It's kind of a black box within the blueprint. But that's why you want to put like all your more complex logic. You can see how like you can collapse a lot of logic into just a single block if you put it into code. And yeah, I'll share this. Please take a closer look later if you would like. I've also included kind of fun other objects. I do some fancier materials over here if you want to check that out. I do like a procedural tire. Yeah. No, we're kind of over time, but I guess I'll wrap there and see if there are any questions I might be able to answer. I'm happy to hang out a little bit longer for anyone who also wants to stay on.
I thought you had to really have, I thought they say to be good at like making games on the Unreal Engine, you have to have some knowledge of C++. What are you saying? Like you have to have like I know you don't use like mostly C++ too often. It's mostly like, just designing the levels and everything, or designing the characters, the enemies and everything. But I thought it was like mostly like you have to have like actually high knowledge of C++ because you're using C++ like right now.
Yes, I would say if you want to, it's like a level of complexity thing, right? Like if you want to build something very complex, I would say it's possible in blueprints, but you might run into like performance constraints at some point. You might just even run into like a code maintainability constraints. Like blueprints are kind of neat because when you hit play in the simulation, it'll show you like the logic flow. But at some point, like that's just too difficult to understand. There are too many connections, even when you try to keep it tidy. So I would say it's not impossible. It's probably not advised. I think the flavor of C++ in Unreal is actually nicer than just straight up C++. It's heavily object oriented, and there is garbage collection. So if you stay within the Unreal framework, it is a much friendlier version of C++.
Right. So like blueprints, just like blueprints, just like you're just testing the thing out. C++ is like you're actually like constructing the project and everything, kind of, right? Can you do construct stuff like where you're like in blueprint mode, or no?
You can. So when you set up a project, you can actually set it up entirely in blueprints. Like there's a mode where you can create a new project that it just expects no C++ code at all. From what I've observed, like in the, in the industry, in the games industry, a lot of projects start in blueprints. They start purely in blueprints, and things are moved to C++ only when there are performance issues. And so I would say, like, if you crack open the code base of like a production game, like a game that's shipping, there's probably more in blueprints than you would expect.
All right.
Great. Thank you, Joyce, again for taking the time to make this workshop. If you guys do want to go over like the recording of it, we will post it on our YouTube. And then if you also want to ask Joyce questions later, you can also message her on our Discord as well. But before we take a picture, does anyone else have any questions?
I actually do.
Go ahead.
Well, specifically about so I noticed that often people would prefer C++, like often if you're doing a collaborative project and you're doing like version controls, I could see why people would want to do an Unreal project and program it using C++, so that like they could actually revert back to like the previous versions of like basically like the code that sort of dictates how the game is going to run. I was wondering, has collaboration been a bit more of a struggle when you're trying to use blueprints?
So it depends a lot on your version control tool. So a lot of most places that use Unreal as their primary tool, they use a versioning system called Perforce. And so what Perforce allows you to do is you can basically lock a file. So one person can work on a file at a time, and that prevents people from making changes to the same file. But what it means is that if I want to work on a file, but you're already working on it, then I can't work on the file. That's all it means. So that's Perforce. I've mostly been using, Unreal with Git, and you're absolutely right. It's not been fun. It's a very manual process, I think, to like basically like if I'm working on something and I know my teammate's working on something, I'll be like, hey, could you not do that until I'm done with my thing? Or like we'll both make our changes and we'll look at them together. And yeah, Perforce, that's it. But if we'll basically sit down and look at our two changes, and we'll be like, well, is your change easier to redo or is my change easier to redo? And then we'll take the one that's harder and then just like redo everything on top of it. So yeah, it's not great. It kind of teaches you to be modular in a way. Like more files is better because you can modify different files that like we discourage like massive blueprints. Sometimes you'll see like these blueprints with just like a wall of scripting and nodes and everything, and that's kind of bad because this is where you run into these issues. So we try to be good about just like maybe like one function, two functions in every blueprint, and that helps.
Sweet.